start thinking about is the industrial robots, manipulators. That's probably the first thing that comes to mind. That started evolving into humanoids, robots that look more than humans. Then what we see more at weddings, the quads, moving into autonomous vehicles. And I'm trying into this sequence to try to make you think about how robotics is not exactly what we think of when we think about robotics. It's not limited to what it used to be. What is this? You guys probably know this. Roomba, vacuum cleaning machine. How many of you have this at home? Only 2 of us. $50. $50 Amazon. Oh, no, not the Roomba. I'm talking about, I meant the one after. No, Roomba I think is about $500 now, maybe the market price. Now, Alexa, for those of you that do not know, is a home automation core that Amazon sells and that can connect to multiple devices at home. And it's beyond that. That could become your entertainment hub. It has very good voice recognition, so you interact with it through voice. It is connected to the internet. It does all the processing in the cloud, and it has a lot of features. I can't get into that. But again, my objective is, in this discussion, to change your perspective of what robotics is, because that could start showing you what the potential of robotics is beyond what we used to think of them as the industrial robots. But why is this happening? Why is this occurring? Primarily, it is because of the convergence of multiple technologies. So we are living at an age where there had been a lot of progress in multiple areas that feed into robotics: hardware, software, the mobile industry, the communication, manufacturing, and different market needs and different applications. I won't get into the social a lot, but also there's a lot of studies showing a lot of the acceptance aspect of it from a social perspective. But this is not really limited only to robotics. This goes beyond that. And that's what the fourth industrial revolution is. So we talk about the first three. What we're referring to is the steam engine, the rail, the trains, moving into electricity, and then the digital age. And now we're talking about the fourth industrial revolution. And this is very exciting because the fourth industrial revolution scope goes beyond robotics. I mean, it's around robotics, it's feeding robotics, but it's beyond that. So we talk about autonomous vehicles, biotechnology, 3D printing and advances in that, IoT, robotics being one of them, AI, material science, and quantum computing. And a lot of these technologies and the growth in market and the advancement in the technology is also feeding each other and causing progress in one into the other. And the difference between this industrial revolution and the previous one, and this is according to Klaus Schwab, who's the founder of WEF, which is the World Economic Forum, and he has a book on this. I suggest that you pick a copy of it and read it, is that there are 3 dimensions that differentiate this industrial revolution from the previous one. The first being the velocity of change. So most of the revolutions in industry have happened at a linear scale, but most of the current changes, we see them occurring at exponential. So any of the analytics that we do at the markets, at the technology growth, they look like they are exponential. So that is exciting. Obviously, there's a lot of fear that can come up around them. I'll touch on that later on. Also, the system's impact and the changes in the system impact. It changes systems. So think about Uber. Think about Airbnb versus what we used to do before and how we used to go to a hotel or how we used to get a cab. There's really a disruptive change to how the systems function, and the depth and the breadth of the change and of the progress. So all of these combined make this a very unique time that we're living in, where all these technologies are coming about to make a lot of changes. One of the manifestations of that, and give an example, if we look at the 3 largest companies back in 1990 in Detroit, which was one of the main hubs of the industry, market capitalizations 36 billion, revenues 250 billion, 1.2 million employees. If we look now at Silicon Valley, closer into 2014, the top 3 companies, market capitalization, $1.09 trillion. Revenue is about the same. But look at the number of employees. Now that could be positive, could be negative, depending how we see these numbers. But just to give you an idea of the difference. When we talk about robotics, we talk about the anatomy of a robotic system. And so it's beyond what we used to imagine back in the days. And by the way, robotics is not a new field. It's a very old field. The terminology has been coined a very long time ago. But it's one of those fields that has suffered significantly because it had overpromised and underdelivered. So if we go back into history and we look back into the 50s, into the 60s, there was a perception that we will create a humanoid, and this humanoid will be like a human, will function like a human, and will do most of the tasks that we could do. Today, that is not feasible yet. Today, we talk about a specialization. Nevertheless, there's a lot of exciting things that are occurring. So when we talk about robotics, we're talking about the inputs that are coming either from data or from sensors or from systems. We're talking about the processing and communication part of it. And then we're talking about the output. So if I look at the architecture of a robotic system, I almost don't see the robot that I had in mind. I might see it somewhere there actuating a small part of the environment. And this change also had happened of where are the robots. So if we look at where the robots are, traditionally they started in the factory, obviously, and that's where the Detroit aspect of the robotics, the automotive industry, was and still is one of the biggest markets for the traditional robots, particularly the manipulators. But that had eventually moved into the fields, agricultural robotics, moved into the home. This is, who knows what this is? It's the cousin of the vacuum cleaner. I intentionally cropped it small so you cannot tell. This is a window cleaner. This is a glass cleaner. A market available, you could buy it now, a few $100s also. I saw a couple of models in China when I was last there. You could just attach it on the robot on the outside and it just goes from one side and cleans it throughout. This is a small household. There's ones that are bigger that are industrial. And now we're talking about us and the robots, that boundary really almost non-existing, where the interfacing and the parts become the same, whether brain interfaces or other forms of interfaces into the robotics. So that, to a lot of people, it is scary, and there's a lot of ethical questions around that, but it's not something that I would want to discuss. When we talk about trends, we're talking about several trends that are occurring in robotics. One of the ones that I enjoy working in is biomimetics. Biomimetics is where we design a system that imitates something in nature, something biological, a process, a structure, a system. The humanoid is the most common example. When you build a robot that looks like a human, you're imitating nature. You're building something that looks like a human. But it is not necessarily always that obvious. It could be that we imitate the way we walk, and we'll talk briefly about that later on if we get a chance. Soft robotics, that's also another big advance that is occurring. So the structure is not made of steel, aluminum, plastic even anymore. It is a soft material. Human augmentation, we've seen that in the arm. So we augment our bodies. IoT and mobile, we do not see a publication or a robot anymore that does not have connectivity. That is becoming something very basic. When I was doing my PhD few years ago, I'm not going to tell you when exact, but we were the first to control robots over the internet between two countries with force feedback, that you can get a force feedback on your hand from what the robot is feeling. This now is becoming a very standard feature. It's not a big deal anymore. It's something that is expected. VR, AR, there's a lot of potential for that. Also, when we talk about the potential for us in Lebanon to contribute to this field, I think that is a big market, whether in robotics or outside robotics. That's another area of progress. Are you giving me a signal of 5 minutes? Okay, good. AI, almost indistinguishable when we talk about robotics and AI. I know they're completely technically different fields, but they're almost becoming always coming together. And maybe one of the biggest progress in robotics is not in the mechanics. And a lot of the exciting work and the publications that we see and even in the industry is not necessarily in the mechanics. It's not in the structure of the robot, but in what that robot is able to do through the artificial intelligence. Vision, that's another interesting area, and we do have some research in that here at AUB, is the perception of the robot, what the robot sees through a camera, and what it understands from it actually sees in the environment, not only through mapping, but also through perception and identification and segmentation of the objects. And the last one is the interfacing and the collaboration. So there's a lot of efforts that are being done around collaborative robotics and swarm robotics. So if I have a field that I want to deploy in it 20 robots, 50 robots. We've seen Intel in the last Olympics. If you've watched the drones, I don't remember the exact number. Anybody remembers what was it? A couple 1,000 robots, drones. If you saw that demonstration that they did with the lights that they sent up and they drew with it different shapes. How do you coordinate that? How do you accomplish the communication within such complex systems? Is something that is now very trendy in robotics research. On the application side, agriculture is one of the biggest one, and I know Berytech has a competition around that, right? So I'll plug in for Berytech on that. The construction domain in different aspects, inspection, even, you know now, one probably you've heard about it, is 3D printing of houses. That is now a very big trend in the field. Medical is an obvious one because of the size of the market and because of the potential revenue savings and improvement in healthcare that we can get through robotics. AUB has one of the two surgical robotics in Lebanon. They're still very expensive now. They're not common to have. But there are a lot of exciting things that are occurring at the smaller scale than the big robots, such as pills that you can swallow, and it could go through the whole body and through the digestion tract and take several measurements, including cameras, and takes pictures from the inside of the body. There are several of those already in the market. Transportation is another big one. You've probably heard of the quad cabs. So they want to do taxis that look like a quad rotor, just a bigger one. So you can actually take a cab from here to AB, just fly, and you don't need an airport to land in it. And Dubai already tested one of those, and there are several cities around the world that are testing these. So this is not something that is in the future. This is something that is very real, that is ongoing. Clearly, the industrial applications are still there and still the biggest market. If we look at the numbers, industry is still the one that employs robots the most. In the service industry is another area. Rescue, search and rescue is a big one. God forbids, if there's a disaster, that's a big domain for robot deployment for search and rescue. We have a project that we're starting with in collaboration with China and with the civil service بلبنان مع الدفاع المدني to develop such robots. And unfortunately, military. Also recently, if you heard in the news, for example, I won't mention it, but there's a big university in South Korea that just signed a big deal with multi-million, I don't know the exact numbers of it, with the biggest weapons manufacturing in South Korea. And they're working on developing AI for weapons. And believe it or not, even here in Lebanon, we get approached by, I will not say who, to develop such technologies. So obviously we say no, but there's even market in the region for such technologies. So it challenges, there are several, as I mentioned, the social and cultural acceptance. This is still one of the big ones. Regulatory, do you let drones fly? Where, how, when? Recently in Lebanon, at least now officially, you're not allowed to fly a quadrotor without a license from the military. Those of you that have one and they fly it on the weekend, do not, because they could stop you. Which most countries, by the way, they have licensing for that. So that's just the right thing to do. Security is another concern. I'll show a video of that. And impacts of job. That's a big discussion about impacts on job. Would this create jobs? Would this take jobs away? I think it depends on what the job is. That's the short answer. There's a lot of studies around that. I'm going to skip this video if we have time. At the end, I'll show it. I wanted to show just a kind of a funny video about the security. The challenges of mainstream robotics, and this is kind of what the focus of our research, of our team, which I come from the Vision and Robotics Lab. There's several faculty members that work there. We work in these domains, which is the robot's awareness. The robot's awareness of itself, the robot's awareness of its performance, and the robot's awareness of the humans in the environment, and how well we could do this, and how well can robot be sustainable. So that vacuum cleaner, how long would it run before I have to charge it again or it would break down? So the first project I want to show you real quick is similar to what you showed, that push recovery. This is Mr. Noel Malouf, the PhD student. Basically, what this robot is doing what humans do when they balance. So it's using both its vision and it's using its internal sensors to perceive a push and recover. And also humans, we're very good at balancing the control based on how we feel those sensory inputs are doing, which means if I close your eyes and I push you, you would not fall. Because what your system is doing is shifting its control from the vision to the internal sensory. If you feel that you're getting dizzy, you start relying on your vision more. And this is what this demonstration in this robot is showing, is that if I close the eyes, the system can tell that the vision quality is going down and it shifts to internal sensors more. And if the eyes are open and there's noise on the sensors, it could shift to the vision more and it can maintain its balance. Another project we worked on is intent recognition for teleoperation. Those of you that raised your hand with the quad rotor, I'm willing to bet that you crashed it the first few times that you flew that quad rotor. Okay, because it's not intuitive. Roll, pitch, raw, thrust, it is very confusing. It's not something that is natural. So in this project, what we're trying to do is use AI, artificial intelligence, and deep learning to try to customize the interface and allow you to use these joysticks, these haptic joysticks that you see at the bottom that are being manipulated for the system to learn what's your preferential way of driving the quad, this very highly dynamic system, and be able to give you the opportunity to drive it in a better way. And so we've developed this system and we've got many people to drive it with and without this, and we've shown that we have an improvement in performance when we apply our strategy, which is effectively trying to understand what your intent of driving is. Now what we're trying to do in this part of the research is we're trying to do kind of like what the keyboard does with autocomplete. As you're typing a word and on your phone, it auto-completes it. So we're trying to see if we can accomplish that when you're driving a quad and you give a command and it just auto-completes what you're trying to do. Guess beyond just going up and down and left and right. The last one I want to talk about, these are very fresh results. Just got this slide from the student yesterday. This is a mapping exercise. This is a robot that uses the laser that is on board to drive in an environment. And as it's driving and collecting the measurements from the laser, it creates a map of the environment. Now, that is prone to many errors because it might not be hitting the right object at the right height. So effectively what we do, we take that map and we display it in real time in HoloLens. How many of you have tried HoloLens? Only one. What do you have? Where do you work? You have HoloLens, you have Alexa. Berytech? Are you Berytech? Okay. Oh, you don't live in Lebanon. Okay. If you guys want to try it, pass by the lab. We'll set up a demo. We have many interesting demos, but this is the one that includes robotics. Effectively, what we do is we display the map for you. HoloLens is glasses that you see through them, but you can have a display on them at the same time. So we could display anything in the environment as you're looking at the environment. And in this case, what we do is we effectively display the map that the robot is mapping. And if you see a mistake, you are able to see that there's a mistake and you're able to trace it. I'm not sure if it's clear here. The user could see that the couch was missed and the table was missed. Tell the robot through the HoloLens, so it would mark, say, there's a chair there. And the camera in the HoloLens will see the click motion. This is a standard HoloLens maneuver. This is the click, and this is double click. So you point at it and you click, and from the camera you could know where the user is pointing, and you can adjust the robot's map accordingly in real time as the robot is navigating and mapping. So, thus the name, the human-aided mapping. So we're trying to have mapping of the environment, but with the human being in the loop. I think there's a lot of potential for HoloLens and a lot of potential for development in VR and AR in general for us. So the future of robotics, real quick, is I don't think we will recognize it for a few years from now. I think already there's many robotic systems that I cannot tell that they're even a robot in the traditional sense. It will become one with the network. It will become one with us, and we will interact with them in a very different way. And even I venture to say that in some cases they're purely software. I mean, we know that already Google coined their algorithms that go search the web as bots. So, you know, even in some of these cases, we might not even have hardware, or we might have software that sends itself to different hardware component through the network. Opportunities for us, the last slide. I think we need to think about new applications. Humanitarian robotics, maybe. Humanitarian domain is something that is of interest for us. find new ways of solving old problems. And in Lebanon, we're fortunate. We have a lot of problems. So I see that as a good thing, by the way. Many of our projects got a lot of attention in the literature is because we've defined unique problems to us in Lebanon. Merge areas of knowledge beyond just networking and robotics, networking and AI, networking and vision, networking and social, robotics and beats whatever your creativity is. Software development, those of you that are interested in robotics and software development, look up ROS, Robotics Operating System. That's a very good start, and if you have the know-how of ROS, that's a very good thing. I mentioned already AR, VR, and AI applications. So I think there's a lot of potential along these lines here for us in Lebanon, particularly at the entrepreneurship and startups level. Thank you again for having me, and thank you for giving me the time.